Hello, welcome to the lecture session on continuous probability distribution. In the discrete probability distribution, we have discussed about the two distributions, that is binomial and Poisson distribution. And coming to the continuous probability distribution, we have the two distributions. One is a Poisson exponential distribution, other one is a normal distribution. So exponential already I have discussed, and today we are going to discuss the normal distribution. The normal distribution formula is given by f of x is equals to 1 upon sigma root 2 pi into e to the power of minus of x minus mu the whole square divided by 2 sigma square. And when we look at this formula, it is a little bit lengthy. Here it is very difficult to remember so many terms and all these things. And here also the limits for x is minus infinity to plus infinity, mu is minus infinity to plus infinity, and sigma is greater than 0. This is known as the normal distribution. So when it comes to the formula, as I told you, it is too many terms are there and it is very difficult to remember. So what we can do is we can use the tables. Let f of x is equal to 1 upon sigma root 2 pi e to the power of minus of x minus mu the whole square divided by 2 sigma square and sigma greater than 0. This implies f of x is greater or equals to 0, and integral from minus infinity to plus infinity f of x dx, that is integral from minus infinity to plus infinity 1 upon sigma root 2 pi e power minus of x minus mu whole square by 2 sigma square dx. This is taking integral on both the sides with the limits minus infinity to plus infinity. When we put t is equals to x minus mu divided by sigma root 2, where x is equal to mu plus sigma root 2 t, then dx will be sigma root 2 into dt because mu becomes 0. That is, t varies from minus infinity to plus infinity. So we get the equation as 1 upon sigma into root 2 pi minus infinity to plus infinity e power minus t square sigma root 2 into dt. Or this sigma root 2 will get cancelled with the left hand side, that is out of the integral. So we get only 1 upon root pi into integral minus infinity to plus infinity e power minus t square into dt. By using the rule of integration, minus infinity to plus infinity can also be written as twice of 0 to infinity e power minus t square of dt. So 2 can be again taken outside, 2 by root pi. When we substitute the limit for the integration, that is e power minus t square dt, by using the gamma function, that's a standard one, root of pi by 2 we get it. So this everything gets cancelled, it will be equals to 1. Next, coming to the mean standard deviation of the normal distribution, we don't have to do the derivation part, we just need to remember the formula for mean, variance and standard deviation. Mean is given by mu, variance is given by sigma square, and the standard deviation is sigma. So the graphical representation for this is a normal curve or a standard normal variate is always in a bell-shaped curve, where in the bell-shaped curve, in the middle of the point it will be 0. After the normal, that is in the middle point, when we take this, after this point it is 0.5. From this point to this point it is 0.5, and from the midpoint to here, this point, it is again 0.5. From this point to this point also 0.5. In total, that is from this point to this point, the end point, it is equals to 1 total. That's a bell-shaped curve we have. In case of a normal distribution, where p is 0 less than or equal to x less than or equals to b, we have the formula that is 1 upon sigma root 2 pi integral from a to b e power minus of x minus mu the whole square by 2 sigma square dx. When we put z is equals to x minus mu divided by sigma, or x is equals to mu plus sigma z, where dx is this one. At x is a, we get z1 is equals to a minus mu by sigma. When x is b, we get b minus mu by sigma. So, p of a to b, where x is varying from a to b, it is given by z1 to z2 e power minus z square by 2 into sigma dz. That is p of a to b, where x is varying from a to b, is given by p of z varying between z1 and z2. So the limits also, it is the same thing. Where z is x minus mu by sigma is called as a standard normal variate. We can note that here, when p of minus infinity to plus infinity of z is 1, p of minus z1 less than or equals to z less than or equals to z1 is equals to 2 times, because in the left hand side of the bell shaped curve also it is 0.5, right side also if you are taking it is symmetrical. Therefore, instead of taking minus z1 and plus z1, we can take it as twice of p of 0 less than or equals to z less than or equals to z, and minus infinity to 0 is same as p of z less than or equals to 0, that is equals to half always, or twice of phi of z1. Similarly, when we come to the right hand side of the bell shaped curve, when we take the right hand side, we can get this one as this one, p of 0 less than or equals to z less than or equals to infinity, or p of z greater or equals to 0, which is half. Next, coming to this point, p of minus infinity less than z less than z1 is p of minus infinity less than z less than or equals to 0 plus this. That is, we can add up the two parts. So this can be further written as z less than or equals to 0 and z less than or equals to less than z1. When we take z less than or equals to 0, we get it as 0.5, and this can be taken as phi of z1, or this is z2 less than or equals to z less than or equals to z1, and we can also take it as 0.5 minus, supposing if anything is less than z1, we can add 0.5 to this, and if anything is greater than z2, we can subtract from the 0.5. Hope it's clear. Now coming to the normal distribution table, we have the normal distribution table like this, and it's given by a bell shaped curve, and it is shown in the diagram here. We can see that after this midpoint till any point, if you observe, it is a tabular value. That is, we can name it as z1. That gives the tabular value here, and you can take the total of this from the point till here, it will be 0.5. Similarly, from this point to this point, it will be again 0.5, and total from here to here, it is 1. So when we refer to any of the points, say for example, here is the line, we can observe this point. If you take it as z1 from the table, we can refer, say for example, z as 0.1, 1.5 or 1 if you are taking, you can refer to the values over here. These are all the values we can consider. Let us say for example 1.00 if you are taking, then it will be this value, or 1.01 if you take, this is the value, or 1, this is 1.03 if you are taking 0.3485, like this we can take. So these are all the values we can observe. How to refer to the table I have explained. Now let's see the example. Evaluate the following. P of z greater or equals to 0.85 and P of z less than or equals to minus 2.43 and P varying between minus 1.64 to minus 0.88. These are the two values we are having. Let's see the calculation. See, first thing is z greater or equals to 0.85. That means z greater or equals to 0 minus less than or equals to 0.85. We have to check it. When it is greater or equals to 0.0, greater or equals to 0, it will be 0.5, and minus, from there we need to subtract phi of 0.85. How do we calculate the phi of 0.85? Just let me go back to the table again. 0.85, here you can observe 3023, that you can observe here. 0.85. See here 0.8, where we can see is 0.8 and 5. 0.85, 3023. Can we see here? 3023. 0.8, then 5. So let's go back here. 3023. So we need to subtract this value from the 0.5. Then what happens? It is 0.1977. Hope it's clear. 0.3023, we have got it from the table, and that needs to be subtracted from the 0.5. So we get this value. Next, it is varying between minus 1.64 to minus 0.88. This is same as the positive values because it is a symmetric one. So anything that is z is between 0 to 1.64 minus 0.88. How do we get it? That is, phi of 1.64 is 4495 and phi of 0.88 is 3106. Let us look at the table again. 1.64, 1.64, 1.64. This is 1.6. You can observe here. Can we observe 1.6 here? Yeah. From here, 1.64, that is 4495. Check it here. 4495. And what is the another point we require is 0.88. Let's come back again. Zero 0.88. So here we can see the 0.8 and 0.88 it is. So let's go straight like this. 0.88. 3106. Hope you can all observe here. 3106. So this it is actually the curve between the points, that is if you take the 2 points here, 1 point here and another 1 point here, the value in between these two we need to get it. So we are getting that values. Yeah, 3106. So when we subtract this, we are getting it. Similarly, when z is lesser than this one, again z greater than 0 minus of this one we have to take it. So 0.5 minus this we get it. When we subtract 0.0075 we are getting it. Next example. If x is normally distributed with the mean 12 and the standard deviation 4, find x greater than or equals to 20, x less than or equals to 20. Given mean is 12 and sigma is 4 and x is 20. So z is given by x minus mu divided by sigma. Let us replace the value of mu and then sigma. We get 20 minus 12 divided by 4. That gives us 2. Now P of x greater or equals to 20, that is p of z greater or equals to 2 and p z greater or equals to 0 minus p of z less than or equals to 2. So phi of 2 we need to calculate. Again, I think you know how to refer to the table. So let's see that one. 0.5 minus phi of 2. So when we refer to the table, it was 4772, and when we subtract from this, we get 0.0228, and that gives us P of next question is P varying between 0 to 20. So it is Z less than or equals to 0 and less than or equals to 2. So we need to add in this case here. Less than or equals to 20 means, when I'll just go to the table here and also see, look at this bell shaped curve. When we take this one, this is less than or equals to 20, suppose this is 20, and previous to that, up from here, this value will be taken from the table, and beyond that, that is 0.5 is there, that has to be added. Previously we were subtracting it, but now we need to add this is total is 0.5, which is to be added. So we can here check it here. 0.5 is added over here, then it will be 0.9772. That means the entire bell shape will be covered almost, leaving a little of this. The total is 1, I said it, so it will be leaving this much. Next example. In a normally distributed 31% items are under 45, 8% of the items are over 65. Find the mean and standard deviation of the distribution. Now they have not given the mean and standard deviation. Instead, they have asked us to find out the mean and standard deviation, giving some data. So P of x less than 45 is 31%. That can be taken as 0.31. Greater than 64 can be taken as 8%, that is 0.08. So x is 45, which implies z is 45 minus mu divided by sigma, which we will call it as z1. And here x is 64 in the second case. So z is equals to 64 minus mu divided by sigma. That gives us z2. Let's call this as equation number 1. So P of z less than z1 is 0.31, which is given here, 0.31. So same thing is taken here. And another one is z greater than z2, which is given as 8%, that is 0.08, which has been taken over here. Now since it is less than something, so 0.5 need to be added, and here it is greater than something, so 0.5, from 0.5 it has to be subtracted. But we don't know what is phi of z1 and what is phi of z2, but we know what exactly this percentage. So we need to calculate what is phi of z1. What is phi of z1? From this, it is 0.5 minus of this, or phi of z1 is 0.31 minus of 0.5. So this gives us phi of z1. Similarly, phi of z2 will be 0.42. We are getting it. Next, 0.42, which can be almost equivalent to 0.4192, which is from the table, which happens to be phi of 1.4. Reverse we need to refer here. Let's see how it has to be. 0.42, I set it as 1.4. Go back to the table. 0.42 is 1.4, I said, right? See, look at this. 4192 is near to 1.4. That is why we are taking. We are not referring 0.41 here, but instead we are referring, because it's the answer. So 4192 refer to 1.4. Anything near to that is 4207. Uh, Compared to this, this is a nearest value. So we are taking this one. Or you can take 1.41 also can be taken. There is nothing wrong in it. So 42 was the answer. So we have taken it as 1.4 as the answer. So I explained how it has to be taken. Similarly, 0.19 also we need to take it. And this is the thing. So Z1 is this, Z2 is 1.4. So minus 0.5 is 45 minus mu by sigma, and this is 1.4 is 64 minus sigma by 64 minus mu by sigma. We are getting the two equations we can refer here. This is one equation we got it, another one equation is that, and we can solve for these two simultaneous equations for mu and sigma. So we get a value of mu as 50, sigma as 10, that we can refer. Thank you.